Today, we're pulling back the curtain on the super high-tech world of smart manufacturing. We're going to uncover the hidden science and, frankly, the revolutionary technology that's changing how everything gets made, from your phone to your car. And you know what? It all starts with a problem that is surprisingly simple.
So let me just ask you this. Think about the last time you were at the grocery store, waiting in line to pay. Got it? Okay, now picture a massive billion-dollar factory floor just buzzing with robots and all kinds of machinery. What on earth could those two places possibly have in common? I mean, they seem like they're worlds apart, right? But they are absolutely connected by a single universal problem.
Yep, that's it. A waiting line problem. At the store, it's you and me in a queue. In a factory, it's all the parts and materials just sitting there, waiting for the next machine to do its thing. And it turns out that mastering that line, that queue, is the absolute secret to making things faster, cheaper, and a whole lot better. And look, while it might seem simple on the surface, figuring out the perfect flow for millions of parts isn't just guesswork. Oh no, there is a deep science behind managing these lines, a whole field of study that's completely critical to how any modern factory works. It's called queuing theory, and this is basically the mathematical backbone of the entire smart factory. It gives engineers the tools to look at the random, kind of chaotic flow of parts and information, and then figure out how to optimize it, how to prevent bottlenecks, and just crank up the efficiency. It's really all about understanding the rhythm of production. So let's break it down. Any production line, no matter how complicated, really comes down to these four basic steps. First, you have the arrival. That's when the raw materials show up. Then there's the wait. That's the queue itself, the buffer zone before a machine. After that comes the service, where a robot or a CNC machine actually does its job. And finally, departure. The part moves on. Every single factory follows this fundamental pattern. So here's the key takeaway. The entire mission of a smart factory, the whole game, is to perfect this flow. Every single piece of technology we're about to talk about is designed to squeeze every last drop of wasted time, energy, and material out of that simple four-step process. Okay, so if queuing theory is the science, what's the tool that actually puts it into practice on the factory floor? Well, the answer is artificial intelligence. It's the brain of the whole operation. And more specifically, smart factories use this really powerful technique called reinforcement learning. The best way to think about it is like training an AI to play a video game. It runs millions and millions of simulations, and it gets rewarded for good decisions, like finding a more efficient way to cut a piece of metal, and it gets penalized for bad ones. It literally learns from experience, figuring out the absolute best thing to do at any given moment. And the results? Well, they're pretty dramatic. Look here. On the left, you have a traditional machine that just follows a fixed program, same thing over and over. But on the right, the AI-powered machine is constantly adapting. It can predict when it's going to break down before it happens. It can optimize for the perfect surface quality while also using less energy. The difference is just night and day. So what does all this add up to? The bottom line is a massive jump in what's called throughput. That's just the number of finished parts a factory can kick out the door. As you can see right here, by making millions of tiny smart decisions every second, AI lets the entire production line move faster. You get way more output without adding a single new machine. It's incredible. This quote from the research really nails it. AI fosters autonomous decision-making. What that really means is it lets the factory start to run itself, making smarter, faster choices than a human ever could 24/7. That means fewer errors, and most importantly, it keeps the line moving. But, a factory isn't an island. It's just one piece of a huge, incredibly complex supply chain with hundreds of different companies all involved. And that brings up a whole new problem: trust. I mean, just think about it for a second. A single part might come from a supplier in one country, get assembled in another, and then inspected by a totally different company. How do you make sure that the data about that part, where it came from, its quality inspection report, is actually accurate and hasn't been messed with along the way? And the answer, maybe surprisingly, is blockchain. Now, forget about cryptocurrency for a minute. In manufacturing, blockchain is like a shared digital rulebook that is impossible to cheat. Every single time a part moves or gets worked on, a new permanent entry is made in this digital ledger that everyone, and I mean everyone in the supply chain, can see and verify for themselves. So let's actually trace a part's journey. Let's say supplier A ships some raw material. Boom. That action is logged, and it's immutable. It can't be changed. Then factory B assembles it.
creating a time-stamped, totally secure record. Then an inspector comes along and certifies the quality, making them accountable and the whole process transparent. By the time it's finally delivered, you have this perfect, unbreakable, traceable history of that part that everyone can trust completely.
And this is the magic right here. This built-in trust changes everything. It means companies can share data securely. It even automates really complex stuff. For example, you can have a smart contract that automatically pays the supplier the exact second its parts pass inspection at the factory. No paperwork, no phone calls, no delays. It's all about making the entire supply chain just as slick and efficient as the factory floor itself.
So let's put it all together. We've got the science to understand the line, the AI to manage it, and the blockchain to secure it. When you combine all of these powerful technologies, what you get is the factory of the future, and it's already operating today. This is what we call the smart factory advantage. You have the AI brain making smarter decisions every millisecond. You have the blockchain shield creating unbreakable trust across the whole supply chain. This optimized flow means less waste, which is great for the planet. All this real-time data leads to way better products with fewer defects. And maybe the most important thing of all, it makes our supply chains more resilient, able to adapt instantly to disruptions happening anywhere in the world.
So I'll just leave you with this final thought. We are very clearly entering an era where the places that make all of our stuff are becoming intelligent, self-managing systems. So what does our world actually look like when every single product we touch is the result of a factory that can truly think for itself?